Good morning, good afternoon, good evening. This is Sriram B from the Tech Advisor team of HCL Automation Orchestration Suite. Today we are looking at a fraudulent transaction detection use case using three different workflows. So we have a pattern analyzer workflow, we have a behavior analyzer workflow, and we have a risk scoring workflow as well. Now, each of these workflows have independent functions. So they're going to continuously monitor an incoming stream of transactions. The pattern analyzer is going to detect anomalies, feed into behavioral models, also catch new trends and define new baselines. And likewise, we have different functionality for each of these workflows. So let's go ahead and see the pattern analyzer in action. So I'm going to go ahead and submit this particular workflow. Now, this in turn is going to look for incoming transactions. So I'm going to mimic some incoming transactions. So the first step is going to pick the AWS SQS message. The second step is going to detect anomalies. So from the incoming stream of transactions, it detected that the user one normally transacts below $200, but there's suddenly a 5,000 transaction. So this is flagged as a high risk transaction based on historical spending. There's also a location based anomaly. User one generally makes transactions in has made a transaction in San Francisco at 1425, while another transaction is made in Paris at 1430. So, given the short time gap, this could again indicate a compromised account or maybe VPN usage. There's also a device based anomaly. So, the first transaction user one made was on a mobile device with iOS on Safari, but the suspicious one was from desktop Linux Firefox. Now, this device was never used before. It may indicate a fraudulent attempt. There's also a velocity based anomaly. User 2 typically makes small transactions in the range of 25 to 50, but there's suddenly a 5,000 jewelry purchase. Now, since the transaction velocity is low, just one transaction in the last 24 hours, it may just be out of character for the user. So, this is the detection of the anomaly, and then we are also um, feeding into the behavioral models. So this is uploaded into an S3 bucket. And there's also another task that is catching new trends. So there are some new trends that are also caught from the incoming stream of transactions. And also we have defined new baselines now based on these new trends. Now, while all of this is happening, there's also a behavior analyzer. Now, this behavior analyzer is also monitoring an incoming stream of transactions, is flagging transactions, and then triggering biometric authentication additionally in case of any suspicious transaction. So, we're going to see this in action as well. I'm again going to mimic a transaction. Now, the first task is monitoring the incoming stream of transactions, getting the SQS message. The second task is going to flag the transaction with AWS SNS as a suspicious transaction. So it's going to send out a notification to the end user that there is a problem with this transaction. The third one is going to trigger biometrics. So it is going to push biometric notifications to the endpoint just to check if the transaction is indeed genuine. So if confirmed, it's going to go ahead, else it's not going to go ahead with the transaction. So this is the behavior analyzer running behind the scenes. And we also have one more risk scorer workflow. Now, this risk scorer workflow is going to evaluate continuous stream of transaction, compute the risk. It's going to block high risk transactions. It's going to hold medium risk transactions and going to approve low risk transactions. Or in case of high risk or medium risk transactions, it's also going to escalate um, to the human. So let's see this in action as it is running. So I'm going to go ahead and again mimic an incoming stream of transactions. So what this in turn is going to do is trigger the risk scorer. So the risk scorer is going to evaluate the stream of transactions, going to pick the AWS SQS message, and then the next step is going to go ahead and compute the risk. Now it computed that there is a high risk transaction with score 92 because multiple anomalies are detected based on amount, location, device, keystroke, and mouse behavior. There's also previous fraud history and device linked to fraudulent activity. There's also a medium risk transaction, large transaction amount detected based on the jewelry purchase, luxury purchase. Um, so we have different risk levels identified. Now, the high risk transaction of user one is going to get blocked because it's about 90%. There's also the medium risk transaction that is going to be held because this is of medium risk. And there's also the low risk transaction that is approved for user 3. And in cases where it is high risk or medium risk, it is also escalated to a human. So a message is sent on AWS SNS, which could be in the form of email, SMS, or Teams message, that there is a problem with these two transactions, so that the human could then get in and um, really analyze if these transactions are genuine, or if there is uh, anything that is fraudulent happening behind the scenes. So we have three different workflows, each having specific functionality to realize this entire scenario end to end. And all these three can work in tandem based on AWS SQS triggers, because UnO can run with AWS SQS events on the fly dynamically. And all of these can run asynchronously together to detect fraudulent transactions. Thank you.